Okay, this is problem number 23 on lesson 5-2, right? That we did. Okay, so last time I didn't get a chance to talk about this in full, but I talked about cofunctions. And the bell was about ready to ring, and so I just kind of talked about it really fast. You need to know that sine and cosine are cofunctions. Tangent and cotangent are cofunctions. And secant and cosecant are cofunctions. What that means is that if you take, if the two angles of these two things, let me give you an example. If you had the sine of 40 degrees, that would be equal to the cosine of 50 degrees. In other words, if your two angles that you're taking the sine and cosine of add up to 90 degrees, then these two things are equal every time. And that's what cofunctions do. I don't know if you guys can see up here on this unit circle right here. And I haven't introduced you to sine and cosine on the unit circle. We'll be doing that soon. But I want you to notice that at 60 degrees, the x value is 1/2. And at 30 degrees, the y value is 1/2. Do you see that? One of these is sine and one of these is cosine. If you took the cosine of 60 degrees, it would be 1/2. And the sine of 30 degrees, it would be 1/2 as well. In other words, the sine of 60, or the cosine of 60 and the sine of 30 are going to have the same value, okay? Because 30 plus 60 makes 90. Anytime your two angles add up to 90 degrees, and you're taking two cofunctions of each other, they're going to be equal. Does that make sense? So, like, the tangent of 10 degrees would be equal to what? The cotangent of 80 degrees, because 80 plus 10 add up to 90, and tangent and cotangent are cofunctions. The secant of, let's say, 28 degrees is equal to what? The cosecant of 62 degrees, right? Because 28 and 62 add up to 90, and secant and cosecant are cofunctions. So how does that relate to this problem right here? If tangent of theta equals 1.3, what is the value of the cotangent of 90 minus theta? 1.3. The cotangent of 90 minus theta equals 1.3. Well, look, put a number in for theta between 0 and 90. Can it give me a number between 0 and 90? 20. If I had 20 right here, the tangent of 20 is 1.3. Down here, what's 90 minus 20? 70. And since cotangent and tangent are cofunctions, and 70 and 20 add up to 90, they're going to be equal, right? So if theta was 20, 90 minus 20 is 70. This would be 70. That would be 20. That's tangent. That's a cotangent. They're cofunctions. They're going to be equal to each other. 1.3. Talon, do you get that? Were you listening? How many of you guys get this? How many of you totally understand it? Raise your hand. How many of you understand these three problems right here? Yeah, you guys. Sine and cosine are cofunctions. Tangent and cotangent, secant and cosecant. This is a really easy concept, you guys, because all you have to do is see if you have two that are cofunctions, which I just listed them right here. Here's the three, right? Those are cofunctions. And if the two angles add up to 90, then they're equal. So 40 plus 50 is 90, and sine and cosine are one of my cofunctions, right? 40 and 50 are 90 degrees. They add up to 90 degrees. They don't have to be equal. They just have to. 10 plus 80 adds up to 90. 828 plus 62 adds up to 90. Well, if let me ask you this: if I said this was tangent 10, isn't 90 minus 80? I mean 90 minus 10, 80? Yeah, and that's what it's saying right here. Whatever angle's right here. If it was 15 degrees, 90 minus 15 would be 75. 75 and 15 make 90. No, well, that's just the value of it. Actually, to get this, let's just say this. I actually think the way they wrote this question is a bad way to do it, given that it's 1.3, because that's only for a specific angle. I don't even know what angle it's for. It doesn't really matter in our case. All we care about is that if you have an angle right here, 90 minus that angle is going to be the complement to that angle. Remember, two angles that add up to 90 are called complementary angles. If the angles are complementary angles, okay, and there's co-functions, then these things are going to be equal to each other. The sine of 40 and 50 are complementary angles, right? They add up to 90. So the sine of one and the cosine of the other are going to be equal to each other. Well, if these two are going to be equal to each other, they both have to be 1.3, don't they? Yeah, they're just saying that they have to be equal. It's just like saying the tangent of theta equals the cotangent of 90 minus theta. We just gave, instead of saying it that way, we gave a value for tangent theta as 1.3. So this one's also 1.3. We spent enough time on that one because that one's really not that important. Yes. If all you care about is the answer, yes. Okay. All right. Yeah, you're right. Okay. Any other questions? Which one? 13. What does it give you? What information? Hey, you guys, isn't it true that slope is y over x, right? The change in y over the change in x. Okay, rise over run, whatever, however you want to say it. Well, if I have that picture that they have right here, they have a triangle going up like this. Wouldn't this be the rise or the y value? And this be the run or the x value? And the slope is being determined from this angle. We'll call it theta right here, right? If I'm looking for the sine, cosine, or tangent that's equivalent to that, which one is it? Because tangent. Because if I took the tangent of theta, that's equal to opposite side over hypotenuse side, which is equal to the y over the x, right? So the answer is tangent. Because if you were asking for the slope of the roof, you would go out there and you would measure. Okay, you would probably measure the horizontal distance and the rise from this angle right here, wouldn't you? You could do it from here as well, but usually when we measure slope, we go from left to right, going up. Yeah, it'd still be tangent because it would just be, well, it would be cotangent actually, because it would be this and over this one. Well, it's from down here, because I mean you're going left to right. Yes. What? Oh, I'm sorry. Yeah, I made a mistake right there, you guys. Sorry. Opposite over adjacent. Did you guys see that mistake I made? I don't want to mess you up. Okay. I just made a mistake when I said hypotenuse. I was thinking adjacent. Opposite over adjacent. Okay? Any other questions? I wouldn't say it's a reciprocal. It's 90 minus whatever that angle is. Oh, yeah. Hey, you guys. I want to do one of those problems on your assignment that has to do with finding the 6 trig functions. Which one would you like to do? I'll just do one. 20? Okay, 20 says what? Let's see. It's a triangle like this, right? Okay. This is a right angle. Is this R up here? And this is S? And T? How long is the hypotenuse? And how long is this side? Okay, and it says find the 6 trig functions. Well, that means find sine of R. It says of R, doesn't it? Cosine of R. Tangent of R. Now, this is an answer to your question, Ellie. Okay? You guys remember that cosecant, secant, and cotangent are just reciprocals of these. So the cosecant of R is a reciprocal of sine. And when we get our answer, all we have to do is flip it over to get this one. Got it? Is that what you're asking? Okay, and this is the secant of R, and this is the cotangent of R. So the secant is a reciprocal of the cosine, and the cotangent is the reciprocal of the tangent. So let's find these ratios. In order to find the ratios, we got to find a missing side. What is it? Well, if we're going from R, it's the opposite side, right? Okay, did anybody figure out what it is yet? 45 point. Okay, let's do that. What did it leave it as? The square root of what? Huh? Really? So this 4 goes into this, I take it. How many times does 4 go into it? We can rewrite this as 4, the square root of 4 times the square root of 527, did you say? Is 427, is 4 times 527 2,108? It is, isn't it? Okay, so, and the square root of 4 is 2. And there must not be any more perfect squares than the number 527. So it reduces it to 2 times the square root of 527. Is that what the book showed? Oh, let me see what my book says for how they put it, what format they put it in. Yeah, they actually reduced it to 2 square root of 527. So that's what we're going to use. Okay, so, yes. Is it wrong if you use 45.9? No, I'll accept it. However, this is what I want you guys to understand about this. You really need to know all formats, because when you take the ACT test, one of the first things I do when I take the ACT test on the math portion, because I always get kids coming in here and asking me to help them with that part, is I look what format the answer's in very first. It'll save you time if you do that, by the way. It's just a good strategy to use on the ACT test. Look at the format the answer's in, because you want to know, are they leaving the answers in square roots? Are they putting decimals? Okay. And there's other formats for different kinds of problems. And so you always want to look at the format, because a lot of times when I forget to look, I'll work through a problem and I'll look down there for my answer, and I went too far because I could have just stopped up here and I would have had my answer. Does that make sense? So I would definitely use that as a test-taking strategy on the ACT test, is look at the format. And the same thing applies to these assignments. If you'll look in the back of the book and see what format the answers are in, that will help you as well. Okay? Will you do that? Okay, so on this problem right here, I'm looking for the sine of R. Well, the sine is equal to what over what? So I got to go opposite of R. Opposite over the hypotenuse. So 2 square root of 527 over the hypotenuse, which is 48. Okay. Cosine would be adjacent over hypotenuse. So 14 over 48, which reduces to 7 over 24, right? The tangent is equal to opposite over adjacent, so 5 root 527 over 14. there's that answer, right? Now, the next three, all I have to do is flip these over to get the answer. So this one, I would write, oh, by the way, 2 goes into 48 24 times. Okay, so that's square root of 527 over 24. Where are you? Oh, is that supposed to be a 2? Yeah, that's right. I don't know where I got the 5. I've done that twice today now. 2 square root of 527 over 14. And so, yeah, that reduces to 527, square root of 527 over 7. All right, hey, how many of you guys know how to rationalize the denominator? You guys have never learned how to rationalize the denominator? Ellie knows how to do it? Well, if I flip this one over to get 24 over the square root of 527, some mathematicians a long time ago decided that we'll never have a format where the answer will have a radical in the denominator. So they do what they call rationalizing, which is getting a radical out of the denominator. And in this case, all you have to do is times the top and bottom by the square root of 527, because that's 1, isn't it? The square root of 527 divided by square root of 527 is 1. And you can times anything by 1, but this certain kind of 1 is just going to change what it looks like. It's not going to change its value. So it's going to be 24 times the square root of 527. And then when you times the square root of 527 times the square root of 527, you get 527. And 2 doesn't go into 527, so that's the answer. Oh, 24, I did it again. Oh my cow. 24 times the square root of 527. I think I was trying to fit it all in there. Okay. Hey, and then right here, this one's easy. Just flip it over, 24/7. But once again, down here, we're going to have to rationalize the denominator. 7 over the square root of 527. So we're going to have to times it by the square root of 527 over the square root of 527, which is 7 square root of 527 all over 527. Someone check to see if 7 goes into 527 for us. You already checked it? And that's what you get right there. Well, it's like this. If you times the square root of 3 times the square root of 3, you're going to get 3. Why? Because the square root of 3 times the square root of 3 is the square root of 9, right? Because 3 times 3 is 9. And what's the square root of 9? 3. It just makes a perfect square that you're taking the square root of. Yep. Okay. Good. See ya. Oh, the question is how did I change the square root of 2,108 to 2 square root of 527? Well, I find the prime factors of 2,108. First of all, I know that 2 will go into that because it's an even number, right? So it will go in 1,000. Yeah, 1,054 times. Well, I can tell that 2 will still go into 1,054. 2 and 527. And someone already determined in here that 527 does not break down into any prime factors that will work. So I have a pair of 2's here, and I have a loner. So I take one of the pairs, goes on the outside, the loner back inside, and I get 2 root 527. Do you remember doing that? Yeah. Okay. Now, do you guys see why you need to know all your square root stuff, simplifying, rationalizing the denominator? On the ACT test, there will definitely be some problems if you don't know how to rationalize the denominator and simplify radicals. You won't know how to do those problems. So you want to make sure on those. Okay, let's move on. We are going to go back a lesson, 5.1. I did 5-2 because it was specifically on what I was supposed to teach next, but I was looking and there's the next couple lessons coming up, plus some of the problems on your assignment require you to know some stuff from 5.1. So I'm going to back up today. We're going to go do lesson 5.1 today. Okay, and in doing so, I need you to do this right here. You guys, I'm going to give you 5 minutes to define all these words in your notes. Okay, these are the basics. If you don't know these words, you'll struggle the whole time. You got to know these words. Longitude and latitude don't matter as much, but you need to know the rest of these really well. Okay. Plus, we're going to learn 2 more words, coterminal angles and reference angles today, that are really important. So I want you to define all those. In fact, I want you to add 2 words to that. I want you guys do I want you to do these 2 words. Coterminal angles and reference angles. So in your notes, you'll want to have all those. I'm going to give you 5 minutes right now to define those. And then we'll go on with the lesson. Oh, go to the library, check one out. Advanced Algebra Pre-Calculus books. Okay, just quickly, I'm just going to give you a quick synopsis of this. First of all, do you guys know what quadrants everything is? Quadrant 1, 2. That's the correct way right there. You need to know that. If you don't know that, in trigonometry, you'll be in trouble, okay? So make sure you know that. Okay, second of all, when we put an angle in standard position, right down here, that one right there, and we put it in standard position, the vertex is always at 0, 0. Okay, and we have what's called an initial side and a terminal side. What does the word initial mean? First, started, beginning, right? The initial side is always on the positive x-axis. Did you learn that in your definition? If you didn't learn that, you ought to write it down. And the terminal side depends on whether you have a positive or negative angle, but we'll talk about that in a second. But the terminal side is where you end up if you turn from the initial side up to something. That side where you end is called terminal side. Terminal means end, okay? Like the Terminator. Ends people's lives. I guess. I've never seen it. The terminal at a airport is where your life ends because you're getting on an airplane. No, I'm just kidding. The terminal, the terminal is where the airport ends and you get on the airplane, right? Okay, so let's. I was just trying to think of words with terminal in it. Terminally ill means you're. None of those sound good, do they? So. Okay, end. Okay. All right. So yeah, but we don't have to talk about end of life all the time. So, all right. Okay, it was my fault. Okay, so initial side, terminal side, we got that? Okay, now positive and negative angles. You always start right here with the initial side. Positive angles always go in which direction? Counterclockwise. So going up like this, and this one right here is a positive angle that I have written here. If I go in the clockwise direction, let's say maybe right there, I get a negative angle. Okay? Those are, and so clockwise is a negative angle. Any questions about that? Now, one thing you're going to find out about in trigonometry, it's not like geometry where we only studied angles between 0 and 180 degrees. We're going to study angles of infinite degrees. Yes, Ellie? You could call it a 270-degree angle, but here's the other part of it. In math and trigonometry, when engineers and people make things, they're not just counting an angle in degrees, they're counting turning in degrees, and direction matters, doesn't it? And so the direction you're turning matters. So that's why we have negative angles. Okay? All right, now degrees, minutes and seconds. Here's an example of an angle in degrees, minutes, and seconds. Okay, that's how you would write it. 27 degrees, 15 minutes, 45 seconds. Now you just should have learned how many minutes are in a degree. 60. And how many seconds in a minute? 60. Let me ask you this. How many minutes or how many seconds in a degree? Not 360. 3,600, because 60 times 60 is 3,600, right? Okay, because there's 60 seconds in a minute and 60 minutes in a degree. Now, one of the things you're going to have to do today is be able to change from degrees to minutes and minutes to degrees, and I'll talk more about degrees, minutes, and seconds on the next slide when we talk about that. Okay, longitude and latitude. Which way do longitude lines go? Up and down, kind of like y-axis, right? Y-axis. And latitude lines are horizontal, so they go around this way, okay? Horizontally. Okay, any questions on that? Okay, now, like I said, one of the things you're going to do is change decimal degrees. By the way, this is in decimal degrees. And we're going to change it to degrees, minutes, seconds. We usually abbreviate that as DMS. Degrees, minutes, seconds. Now, I told you guys about the Trig Star test that we're going to be having in March after we come back from spring break. We have the opportunity to win $200, $150. And it's only this class and my other honors class in secondary math 3 that are going to probably be taking it. All the kids like in calculus or those higher level classes, they've already taken it before. So like some of the kids in your grade that took pre-calculus last year. So it says Nephi and Sean Hebner, Justin Bias, and those guys. Those guys took it last year, so they don't get to take it again. So it's just you guys and my other class. Somebody in here could win $200. Okay? And last year, I got to tell you, it wasn't who I thought was going to win it. It was who? Kyle Rasmussen. And the reason I say it, Kyle's good at math, but he didn't always apply himself. But when I put dollar signs up there, he went home and studied, and he did well on it. Okay, so we're gonna find out who likes dollar signs in here. So, huh? Yeah. If I had any money, maybe. All right. Hey, you got to think of it as money, because when you guys learn this stuff, they found out they've proven that the more math person knows, the more money they make in life. There you go. If they doctors do make, but they don't take a lot of math. They just take up through calculus. A lot of math would be way beyond calculus. Engineers, scientists. I think lawyers take up through calculus too. Calculus, beyond pre-calculus. Calculus? Yeah. Well, no. Most colleges don't require calculus to graduate. For your general education, most majors require college algebra, but some of them just require up through Math 1010, which is like Algebra 2. Okay. All right. Here we go. This is how you do it. Okay. We have 15.735 degrees. What you're going to do is we know that the 15 is the degrees, right? Now you're going to take, now we got to figure out the minutes and the seconds, okay? So you're going to take the numbers behind the decimal, the 0.735, and you're going to times it by 60. Everybody do that in your calculator right now. 0.735 times 60. And what do you get? 44.1. That part that's in front of the decimal, the 44, is your minutes. Then you take the decimal behind the 44, the 0.1, and you times that by 60. What do you get? 6. And so that number right there is the seconds. Now, if you were to have a decimal, like if this was 6.78, you'd just write 6.78 seconds. Okay? So that was what, Colby? It could be. I don't know which way it goes. I don't know if the clocks came from this or the clock or the unit circle. I'm pretty sure the unit circle came first. Okay, so that's how you change decimal degrees to degrees, minutes, seconds. Any questions on that? I would suggest having that example written down in your book so you know it. Or you can do it this way. You can type in 15.735. Above apps, it says angle. Access the angle menu, second apps. And number 4 says DMS. That means degrees, minutes, seconds. Paste it back to the home screen. Hit enter. 15 degrees, 44 minutes, 6 seconds. What? And get the decimal? Yes, that's what we're doing next. Good job, Dre. Okay. So we got that. All right. Now, I would write this one down too. How to change degrees, minutes, seconds. So we're going to write degrees, minutes, seconds converted to decimal degrees. All you have to do is this, 39 plus 5 divided by what do you think? 60 plus 34 divided by what do you think? 3,600. Because it's in the seconds place. And put that in your calculator, and you'll get the answer. So tell me what it is. 15. That's 39 right there. It's going to be 39 point something. 39 point what, Kyson? 092? 39.092 degrees. We should put degrees behind it, right? Yeah. Okay. That's how you change those. I'm not going to spend any more time on it than that. You should have written this down. You can come back and review the video if you need to. Okay, we got to talk about quadrantal angles and coterminal angles really quickly. I should have had you guys look up quadrantal angles, but quadrantal angles are pretty easy. It's just, all it is the angles where the terminal side is on an axis. An angle whose terminal side are multiples of 90. An angle whose terminal side is on an axis. Okay, so like, you guys, examples would be 90-degree angles, 180-degree angle, negative 90-degree angle, 270-degree angle, 360-degree angle, and so on forever. Any multiple of 90 degrees is going to be a quadrantal angle because its terminal side is always going to be on one of the axes. Okay? What I would like you guys to do is find an angle coterminal to 45 degrees in your groups. I'm going to give you 30 seconds. Go. Just one. One angle. Oh, wait. We haven't talked about coterminal angles. You guys looked them up, though, right? Okay. Two angles with the same terminal side. That's the definition. Did you all get that? What did your definition say, Ellie? All right, let's just write this down, okay? Let's say I have a 75-degree angle. Say that's 75 degrees, okay? I want an angle coterminal to it. So it's coterminal to it. I can just add 360 to that. What's 360 plus 75? 435-degree angle. Let me show you a picture of what a 435-degree angle looks like. You started right here on the initial side. You would go all the way around 360 degrees plus 75 degrees, and you would end up with an angle of 435 degrees. Okay? So if you're an engineer and you have to manufacture that goes something 435 degrees, you know it's a 75-degree angle plus a full turn around the circle. Add 360. That's it. Now, let me ask you this. What is a negative angle that's coterminal to 45 degrees? Discuss that in your groups. When your group has it, everybody in your group raise your hand. Talk about it. Coterminal to 75 degrees. I'm sorry, to 75 degrees. Thank you. Yeah, you guys. For the 75-degree angle, all you do is go 75 minus 360, and what did you get? Negative 285. There is a negative angle. Okay. Now, this is what I want you to do. On A and B, okay, listen for the instructions, you guys. I want you to name two angles, two positive angles that are coterminal to 45, and two negative angles coterminal to 45. And yeah, two positive and two negative. And then the same right here with 225. Two positive and two negative angles coterminal to 225. No, because this is 45 degrees. I want a different angle. A different angle. Yep. Okay, go. This table right back here. Give me one for 45 degrees. It's a positive one. What? 765. Give me another one, this table right here. 405. Give me a negative one right here, this table. Negative 315. Give me another negative one, that table. Negative 675. Good. Okay, 225, this table right here, a positive one. 585. This table right here, another one. That table right there, a negative one. That's 45 degrees. We're looking for 225. Negative 135. That table right back there, another one, negative. Negative 495. Any questions on this? Does everybody agree with those? Yes. Okay, right here. No, this one right here says if each angle is in standard position, determine coterminal angles that's between 0 and 360 for it. And then state the quadrant in which it lies. Go. Both of them. Which angle is that? Which quadrant is that in? Quadrant 1. Okay. 5. That would be you guys. Okay. Wait, you haven't done it yet? What were you guys doing? That's the blonde. That is the blonde table. You're right. Should I ask someone else? A non-blonde table? All right. I'm going to ask a red table. 4. That's you guys. What is the answer to this one? What's the Huh? 149? All right, you guys, it's 143. Which quadrant is that in? Quadrant 2. That's quadrant 1. Between 0 and 360. That's a positive angle, between 0 and 360. Okay? By the way, backing up, hey, you guys, this thing, I don't know if you noticed, it says identify all the angles that are coterminal with each angle. Well, how many are there? Infinite number, right? So how do I express that? 45 degrees plus 360. K. What does K stand for? It stands for an integer. Okay? We're not talking about money right here. This is not thousands, 10K dollars or anything like that. We're not talking about races either. 10 kilometers, you know. Okay, this K stands for an integer. An integer is a whole number, right? Or its opposite. So if I put 1 in here, 45 plus 360. If I put 2 in here, 45 plus 720, right? Get the idea? If I put 0 in here, it'd just be 45. If I put negative 1 in here, it would be 45 minus 360. If I put negative 2 in here, it would be 45 minus 720. Got it? And that would cover all of them. It would give us all the angles coterminal to it. Okay. Next one. Reference angles. You guys, for some reason, students have a hard time understanding this concept. It's some students. Okay? So pay attention. Tyson, pay attention back there because you guys are going to want to know this. Okay, you guys should have read in there already, got a definition. What was your definition of reference angles when you looked it up? One person. Who wants to give it? By raising a hand. Audrey, go ahead. Reference angles. Yep, what'd you get? Okay, the acute angle formed by the terminal side of the given angle and the x-axis, right? Now, so let's say I have an angle right here in the first quadrant. Let's say it's 60 degrees. Well, it forms a coterminal angle. I mean, it forms an acute angle. That's what I meant to say. It forms an acute angle, and its terminal side and the x-axis are right here. And so any angle in the first quadrant, its reference angle is the same as that angle. So it's 60 degrees. Let me give you an example of one over in the second quadrant. Let's say I have something like 150 degree angle. So I turn it all the way around to 150 degrees. Now, 150 degrees is not an acute angle, is it? Okay, and I want to go between the acute angle that's formed by the terminal side, that's this side, and the x-axis, which would be this x-axis, not the positive one, because the positive one would form an obtuse angle. We want an acute angle right here. Well, if this is 150, what's this angle right here? So 30 degrees is the reference angle to a 150 degree angle. Can you have negative reference? No, because when we talk about a reference angle, we're always talking about a positive. So it doesn't matter what quadrant it is, whether your initial angle was positive or negative, you always just name the positive angle that's termed.
So if it's like whatever hits at 180, would that mean it's the same as the supplementary angle? Or?
Not necessarily. Watch, because let me go around the circle, and I'll show you some more. Well, let's say I have an angle of, let's go 235 degrees. Okay? Let's say I have a 235 degree angle. Well, once again, what's the reference angle to a 235 degree angle? It's not 35 degrees. Rebecca said it. 55 degrees. Because it's this angle going back this direction, right? It's got to be between the x-axis and the terminal side so that it's an acute angle. So it can't be the angle over here because that's an obtuse angle. Okay? So if you go back up, if you take 180 and you minus 235, you get a negative 55 degrees, but really we just want to know what the angle measure is, which is 55 degrees. So it's always going to be a positive angle. So it's a 55-degree angle is the reference angle. You'll see why later on why we need to know reference angles, because later on in our trigonometry you need to know them in order to figure out problems. Okay, so in the third quadrant, that's how you get it. Okay, let's say I have one clear into the fourth quadrant. Let's say I have 325 degrees. 325-degree angle. What is its reference angle? What? It is 35. Because how many more degrees do you have to get to there? So all it is 360 minus 325 in that case. It's the angle between, it's the acute angle between the x-axis and the terminal side. Between the x, you guys got to remember, it's never going to be between the y-axis. The most common mistake that most students make when finding reference angles is they go the angle between the y-axis and the terminal side. It's always between the x-axis and the terminal side. Acute angle between the x-axis and the terminal side. You might want to highlight that. It's not between the y-axis, it's between the x-axis and the terminal side. Okay, so in your groups, quickly, this is last slide, and then I'll give you the assignment. I want you guys to find the measure of the reference angle for each of these two in your groups. Go ahead. So the first one was 60. Rolling again. 2. That's you guys. 45 degrees. What do you guys think? Yeah, because if you're right here, negative 135 would be turning right to there, right? That's the 45-degree angle in the third quadrant, so it's only 45 degrees back to right there. Okay, good. Okay, any questions? Okay, your assignment. It's right there.